All right, so in Unit 4, there's just 5 main concepts you got to know. Factor theorem, polynomial remainder theorem, rational root theorem, long division, and synthetic division. I'll be doing some Regents practice problems for y'all. Okay, so the factor theorem basically states that if x minus c is a factor of p of x, then p of c is equal to 0. What does this mean? Well, let's say if I have a function p of x, and this is equal to x squared plus 5x plus 6. Well, if I'm given that x plus 3 is a factor of this polynomial, then that means that if I plug in p of -3, I should get 0. And you can actually plug -3 in for yourself. -3 squared is just 9. 5 times -3 is -15. So 9 minus 15 plus 6 is equal to 0. The factor theorem sort of makes sense because, well, I can factor out this polynomial. If you remember factoring, this factors out to x plus 3 times x plus 2. And notice how if I plug in p of -3 into this x plus 3, well, -3 plus 3 gives me 0. And 0 times whatever this is also 0. Okay? So, the factor theorem kind of makes sense because, well, in this example right over here, I can just factor it. And whether I plug in I can actually plug in p of -2, right? If you see that x squared plus 5x plus 6 has two factors. It has x plus 3 as a factor and x plus 2 as a factor. So that means that if I plug in p of -3, so p of negative of this number right over here, I'm going to get 0 because of the, I plug in -3 here. This makes it 0, so 0 times whatever this is 0. And if I plug in p of -2, well, -2 plus 2 gives me 0, and 0 times whatever this is 0, right? And the good thing about the factor theorem is that it can extend to higher order polynomials, or higher degree polynomials. So if I have a function p of x, and this is equal to x to, let's say, 5th power plus, and then blah, 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 and then I'm given x plus 3 is a factor of this polynomial, or let's say I'm given x plus 5 is a factor of this polynomial, well, then that means that p of -5 is going to be equal to 0, okay? Now, let's actually learn how to do long division and synthetic division. So this is just going to be a quick review. Let's say if I have 2x squared minus 3x plus 4, and divide this by x minus 1. Now, we are going to do the long division first, okay? So the long division method. So what we're going to do is I'm going to take this 2x squared minus 3x plus 4. I'm going to place it inside my division thing. So it's sort of like, the setup is sort of like normal division, okay? Where you have your dividend on the inside and the divisor, what you're dividing by, on the outside. Now what you're going to do is you're going to ask yourself, what multiplied by x gives you 2x to the second power? And the answer is just 2x, right? So 2x times x gives me 2x to the second power. What I'm going to do with the 2x I'm going to distribute this to these two terms. Basically, 2x times x gives me 2x squared, and 2x times -1 gives me -2x, right? So it's sort of like I distribute this 2x to these two terms. I'm going to subtract. Now I'm going to subtract. So these 2x squares cancel out, and -3x minus -2x, well, negative makes a positive. So I'm just going to be left with -x. Now, what multiplied by x gives me -x? Well, that's just going to be -1, right? So now what I'm going to do is I'm going to take the -1, redistribute it back to these two terms. So I'm going to get -x, and -1 times -1 is equal to +1. And don't forget, we got to bring down the 4 as well. I should have said this earlier, but we have to bring down the 4 as well, right? And we're now going to subtract. So -x minus -x, well, that's going to cancel out, right? Because negative makes a positive. So, -x plus +x cancels out. And 4 minus 1 gives me 3, right? So these cancel out, and I just get 4 minus 1, which is 3. Now, after doing this process for some time, you're going to be left with a constant term, so a term without an x. And that's when you stop, okay? This is when you stop doing this process. Now, the answer to this problem is you're going to take this thing right up top, you're going to plop it down. What you're going to do is you're going to put a plus symbol. You're going to put a plus symbol, and you're going to write a fraction. So there's going to be something on the top and something on the bottom. All right, so you're just going to do a fraction. This number that you get up top, this number, this constant you get is going to be placed up top. And then this divisor, the thing you're dividing by, is going to be placed on the bottom. And that's going to be your answer to this problem. All right, so remember, your remainder, or this constant right over here, all right, so this constant represents basically the remainder for your problem. You're going to place this up top, and you're going to place the divisor down low. And that's going to be the answer to this problem. Might be wondering, that's kind of a really random strategy. Well, the thing is that you've kind of been doing this strategy the whole time. Think about if you're dividing 5 divided by 2. 5 divided by 2 is 2 1/2. Well, how can I get 2 1/2 using long division? Well, what I do is I set up, right, my long division table. I do 5, and I put this 2 on the outside, right, because it's 5 divided by 2. Now, doing long division, and hopefully you know how to do long division by now, but you're going to notice that you get a remainder of 1. So kind of, you're going to do the same strategy as you did before. You're going to take whatever you have up top, and you're going to plop it down. So you're going to take this 2, you're going to plop it down. And you're going to create this fraction where you're going to have the remainder, or your constant, up top, and the divisor, whatever you're dividing by, down low. So 5 divided by 2 gives you 2 plus 1/2, or 2 1/2 long division. So instead of long division, you can also use synthetic division. However, it's important to know that synthetic division only works if you have a 1x on the denominator. So in this case, I'm dividing my numerator by a 1x minus something. Or it can be a 1x plus something, but the key point to know is that synthetic division only works if you have a 1x on the denominator. If I had, let's say, my numerator divided by 2x, I can't use synthetic division, okay? So what I'm going to do is, notice how actually for both methods, for long division and synthetic division, I'm going to need my polynomial in the numerator to be written in standard form, meaning that I have my highest power to my lowest power, right? That's standard form for a polynomial. What I'm going to do now is I'm going to write all the digits in this box. So 2, -3, 4, right? It's going to be the same division box. And I'm going to put a 1 on the outside because you're going to look at your denominator and you're going to ask yourself basically, what value of x do I have to plug in to make my denominator equal to 0? And if you plug in 1 in for x, 1 minus 1 gives you 0. Now what you're going to do is, I like to draw this line up at the bottom, and I like to draw this addition sign. What I do first, I bring down my first term, so I get this 2. I multiply my 2 by the 1, so 2 times 1 is 2. Then I'm going to add these two terms together, right? This is why I put this addition sign up there. -3 plus 2 gives me -1. I multiply these two things out together. I get -1, right? Because -1 times 1 gives me -1. I add these two terms up, and I get this. Now, your last column represents the remainder. So 3 is actually our remainder for this problem. Okay. Now, the thing about this right over here is that what you have to realize is that if you're dividing 2x to the second power, blah, 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 and you're dividing it by an x, you're going to be left with 2x to the first power, right? Because if you're dividing this second power by this x to the first power, you're going to end up with this 2x to the first power, right? If you remember the exponent rules. So this 2 right over here is actually 2x to the first power, right? Because the power of your answer, so the power of your answer is always 1 less than the power that you started with, okay? And then you're going to write this -1, right? You can think about this -1 as -1 to the -1 times x to the 0th power, right? So all of this is in standard form. And then this 3 is your remainder. So remember what you do with the remainder. You put the remainder up top, and then you put this x minus 1 down at the bottom. And that's going to be your answer. Notice how it's the exact same as what we got for long division. This 2, -1, 3 basically represents the digits here. It represents the digits here in order in standard form, okay? Now, the polynomial remainder theorem is important because it's kind of like a shortcut way of getting the remainder. So let's say if I gave you this problem right over here, and I ask you, what is the remainder? What is the remainder of this division, all right? So I'm not asking you to get the answer to this problem. I'm just asking you to get what is the remainder for this problem. And obviously, you can get the remainder by doing either of these two methods, but that takes a long time. I need a shortcut. So you have the polynomial remainder theorem. This basically states that p of x, you're dividing it by x minus a, the remainder is p of a. So let's apply this here. So imagine if my numerator is p of x, And in this case, I have x minus a, where a is equal to 1, as you can see, right? So that means that if I plug in p of 1, I should get my remainder, right? So if my numerator right over here is p of x, right? So p of x is equal to 2x to the second power minus 3x plus 4, right? And I'm trying to find out what p of 1 is equal to, right? Because I'm dividing by x minus 1. So if I plug in 1 in for x, I get 2 times 1, which is just 2, negative 3 times 1, which is just negative 3. 2 minus 3 is negative 1, and negative 1 plus 4 gives me 3. And notice how it gives me the remainder, and I don't actually have to do all of this work, right? So polynomial remainder theorem is just a shortcut way of getting the remainder. We can do another example. Let's say if I have x squared minus 10x plus 1, and I divide it by x minus 1, and I want you to find out the remainder. Actually, let's do x plus 3. I want you to find out the remainder for this division. So what you're going to do is you're going to make this numerator equal to p of x. And in this case, you're dividing it by x. You can think about x plus 3 as x minus negative 3. So notice how your a is going to be equal to negative 3. So what we're going to do is we're going to plug in p of negative 3 into my numerator and see what that does. So in this case, I have negative 3 squared, right? Because that's p of negative 3, right? Negative 3 squared minus 10 times negative 3 plus 1. So this is going to be 9, this is going to be plus 30, and this is going to be plus 1. So I'm going to get 40 for my remainder. And just one more quick thing. When you're doing long division, for example, if I have this divided by this, so I have x to the third power, plus 2x to the second power, and you don't want to just put a plus 5, okay? You want to put a plus 0x, and then a plus 5. All right, whenever you're doing polynomial division or even synthetic division, you notice that you kind of skip a power. So notice how we go from x to the second power and we skip an x to the first power because there is no x to the first power. In that place, you actually have to put a 0x to the first power there, okay? If you were doing synthetic division, the setup would actually be, so you're going to have your 5 on the outside. So you're going to have 5 on the outside, because if you plug in 5 in for x, you're going to have 0 for the denominator, so you're going to have 5 on the outside. And then the coefficients for these terms are, you have a 1 x to the third power, you have a 2 x to the second power, then you have a 0 x to the first power, and then you have a 5 as your constant. So make sure when you're doing these problems, you're checking if there's any like skipping. Let's say if I have f of x is equal to x to the third power plus 5x plus 6. And I want to find out what are the roots, or sometimes it's known as the zeros of this polynomial. How would I do this? And the rational root theorem basically gives you possible roots for your polynomial. I can't use the quadratic formula and I can't really factor this. So how can I find the zeros? And you would have to use the rational root theorem. Basically, you take your factors of your constant. So basically the p right over here represents the factors of the constant term, of your constant term. So what are the factors of 6? Well, the factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 4. Plus or minus 6, sorry. And then you divide it by q, where q basically represents the factors of your leading coefficient. I'm just going to put LC. This stands for the leading coefficient. Basically, it's the coefficient of the term with the highest power. So what's my highest power? X to the third power. And what's the coefficient of x to the third power? A 1. So what are the factors of 1? Well, that's just going to be plus or minus 1. And basically, this list gives you the possible sort of roots for this polynomial. And actually, I can actually simplify this. So all of this actually simplifies out to just plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Right? Because if you divide plus or minus 1 by plus or minus 1, you either get plus or minus 1 right? And then the same goes with all these other terms, right? You can divide -3 by -1, you get +3, or you can divide -3 by +1, and you get -3, right? So it's going to be plus or minus 3. And for this polynomial, there's like there can be, infinite roots you can guess for this polynomial, but with the rational root theorem, you can get a select few that you can choose from and see if it's actually. One thing I can do is, let's just say, I don't know, I plug in 1 into my polynomial. So I'm going to get, if I plug in +1 for my polynomial, I'm going to get f of 1 is equal to 1 times 1, which is just 1, plus 5 times 1, which is just 1, plus 6, and I get 8. Now notice how when I plug in f of 1, I don't get 0. So when I plug in f of 1, I do not get 0. And this means that x minus 1 is not a factor. You might be confused about what I'm saying, right? What do you mean x minus 1 is not a factor? Well, take a look at what we learned before, the factor theorem. If x minus c is a factor of p of x, then p of c is equal to 0. But likewise, if x minus c is not a factor of p of x, then p of c is not equal to 0. Okay, so that's the good thing about the factor theorem. If in this case, right, if I plug in in this case, I plug in f of 1, and it's not equal to 0, well, that means that x minus 1 is not a factor of p of x, or in this case, f of x, because that's the function we're dealing with. And, I can use the factor theorem, and, I could just plug in all of these numbers, check if f of whatever that number is, not equal to 0, or if it is equal to 0, and then I could determine if it's a factor or not. So let's just say I pick a -1 next. So let's say if I want to find out what f of -1 is equal to, and I plug this into my function. So -1 to the third power is just going to be equal to -1. So -1 times 1 is -1. 5 times -1 is going to be -5. And then this is going to be plus 6. And notice how f of -1 is equal to 0, meaning that x plus 1 is a factor. X plus 1 is a factor of this polynomial. Right? Remember, if x minus c is a factor, then p of c is equal to 0. So in this case, if p of -1 is equal to 0, then x minus -1, or just x plus 1, is a factor of p of x. All right. So that's the rational root theorem. And let's just do some problems with this. Which expression is a factor of whatever this thing is? What expression is a factor of this? Let me actually not use this color. Let me use blue. Okay. So if I want to find out which of this is a factor of it, I can just graph it, right? If I want to know if it's a factor of this, then one method I can do is I can just graph it, right? So I'm going to have x to the fourth power plus, and then actually no, it's going to be minus x to the third power, and it's going to be minus 11, and x to the second power, and then plus 5x plus 30. And notice how when I graph it, it's going to have a 0 here and a 0 here. Now let's take a look. So actually, if I go to calc and I go to 0, all right, I'm going to press this, and I'm going to go to the right of this sort of mini parabola, and I'm going to press enter, right? I'm going to press enter, and it's actually going to tell me the 0. So we basically found out that at x is equal to -2, we have a 0 there. Or in other terms, f of -2, right? When we plug in -2 in for x, we get out a 0 for y. Now, what does this tell us? Well, we can look at the factor theorem. If p, in this case, if p of -2, is equal to 0, then that means x minus -2, or just x plus 2, has to be a factor of p of x. So x plus 2, so that means that x plus 2 is a factor of this polynomial, meaning that number 1 is going to be our answer. You might be saying, well, why can't it be the other answers? Well, I mean, number 2, the answer choice number 2 is just trying to confuse you, because answer choice number 1 and 2 look pretty similar. But if we go maybe to the other side of the parabola, so let's just go to the other side of the parabola. The other side of the parabola, so let me Let me actually do this. So the other side of parabola, at x is equal to 2.236 whatever, our y value is 0. However, you notice how there is no x plus 2.2, x minus 2.230 whatever. So, that's not on there. And likewise, if we try to find out a 0 on this side of the parabola, so let's say on this side of the parabola, right, at x is equal to 3, our y value is equal to 0. Right? When x is equal to 3, our y value is equal to 0, or in other words, f of 3 is equal to 0, meaning that x minus 3 is a factor of this. However, that's just not on our answer choices. So, they're just trying to trick us with these fake answer choices. There is more factors to this, but, it's just not on the answer list. Given x is not equal to -3, and that kind of makes sense. So, if we plug in -3 in for x, our denominator is going to be equal to 0. So, we can't divide by 0. All right, given x is not equal to -3, which expression is equal to this? All right, so they're basically asking us to divide it. All right, that's pretty light. We can use synthetic division. Remember, our coefficients go here, right? Go on the inside. So we have 2, 3, 2, 3, -4, and 5. On the outside, we have a -3 because -3 plus 3 gives me 0 for my denominator. Now, what I'm going to do, draw a line, put an addition sign, bring the first term down, then I multiply this 2 by this -3, so I get -6. I add these two terms, I get -3. Then I multiply these two terms together, and I get 9. -4 plus 9 gives me 5. Multiply these two terms out, I get -15. And 5 minus 15 is -10. Remember that your last column represents the remainder. Okay, so this -10 is our remainder. All right, now let's write our answer out. So when we divide 2x to the third power, by an x, we're going to be left with 2x to the second power, right? So that's exactly what we have here. This right over here represents 2x to the second power. This -3 right over here represents -3x. And then this 5 over here represents a +5. Because remember, this right over here, we're going in order, right? This represents sort of like a standard form for a polynomial, right? Where this is our highest power, then we go 1 power below, then we go 1 power below once again. So whenever you're doing this synthetic division, remember that each of these, terms has a lower and one lower power compared to the other term. And as for our remainder, remember, we have this fraction and we have our remainder up top. And then the thing we're dividing by, in this case, we're dividing by x plus 3. So we have x plus 3 on the bottom. Let's take a look at our answer choices. And all right, number 2 looks to be our answer. The expression x squared plus 6 and x squared plus 4 divided by x squared plus 4 is equal to what? So I have x squared plus 6, and I'm dividing this by x squared plus 4. So what multiplied by x squared gives me x squared? That's just going to be 1, right? Because 1 times x squared gives me that. So we're going to distribute this to both these terms. So I'm just going to get x squared plus 4. Remember, we subtract these two things, so x squared just cancel out. I'm going to get 6 minus 4, which is 2. Now 2 is going to be our remainder. So we're going to have our thing at the top, which we're going to plop down. And then it's going to be plus 2 divided by, and then our divisor. Remember, remainder goes on top, divisor goes on the bottom. And this is going to be this. Now we can also check our work. If you're unsure if, number 4 is the correct answer, you can always use your TI-84 calculator. The way to check your work is, all right, so I'm going to pull up y equals. Now here's my logic, okay? So imagine if you have, 10 divided by 2. That's equal to 5, right? So if 10 divided by 2 is 5, then that means 5 times 2 gives me 10. Likewise, if x squared plus 6 divided by x squared plus 4 gives me whatever this is, then that means if I multiply these two things together, they should get me back x squared plus 6. And if these two things multiplied by each other and this x squared plus 6 is equal to each other, then that means their graphs have to be equal to each other as well, meaning that, so what I'm going to do is I'm going to put in the functions. So what I'm dividing by is x squared plus 4, and we're going to multiply this by our answer, what we got, so 1 plus 2 divided by x squared plus 4, x squared plus 4, yeah. Make sure you put parentheses, to indicate that you're dividing by the whole thing, and then we're going to set that equal to x squared plus 6, right? Because if these two things multiplied out together is equal to x squared plus 6, then the graphs of these two things multiplied out should be the same as the graph of x squared plus 6. And it is, meaning that number 4 is our answer. Find all values of x for which this expression is defined. For all values which this expression is defined, this is equivalent to what? What is this equivalent to? Well, I mean, first of all, when it's saying for all values for which this expression is defined, it's basically saying, x, our x value can't be equal to, for our denominator right over here, I can actually factor this out to be x plus 3 times x plus 2. And this basically just means that x cannot be equal to negative 3, and it can't be equal to negative 2, because, it makes our denominator equal to 0, and you can't divide by 0, right? So when saying for all values for which this expression is defined, it's basically saying for all values of x that are not equal to negative 3 and negative 2, so they do have a defined value, right? What is this equal to? Now for my numerator, I know my denominator can factor to be out this, but for my numerator, I can factor out an x from these two terms. So I get x times x plus 3. And notice how my x plus 3 and x plus 3 cancels out, right? So I'm just going to be left with x divided by x plus 2. And that's going to be my answer, which is number 2. Okay? So kind of another thing for Unit 4 polynomial division is that if you know you're factoring, then, you should be good on this, but you have to know how to simplify expressions. So basically, for example, if I have x squared plus, 10x plus 21, and I divide this by x squared plus 9x plus 14. Well, if I want to simplify this, I can factor both the numerator and the denominator. So x plus 7 times x plus 3, right? Because we just find two numbers that multiply out to be 21 and add up to be 10. So 7 times 3 gives me 21, and 7 plus 3 gives me 10. And for our denominator, I can factor this out to be x plus 7 times x plus 2. Notice how the x plus 7s cancel out. So I just get a simplified version. I just get x plus 3 divided by x plus 2, and that's going to be our answer. That's going to be the simplified version for all defined values of x, basically. So, if you know how to factor, some questions like these are very similar, except, you might have to do factoring by grouping. But basically, if you know you're factoring, then, well, you know how to, simplify these expressions. Just find a common term, just cancel them out, and you get your answer. But make sure that when you get your answer, you don't do this, okay? If you get x plus 3 divided by x plus 2, do not cancel out the x's. That's not how it works. The reason why we're able to cancel out this x plus 7 and this x plus 7 on the bottom is because they were multiplied by something. In this case, our x is actually being added to something. And when you're adding or subtracting it to something, then you can't cancel it out. But if you're multiplying it by something, then you can cancel it out. All right, think about if you have, let's say, 4 divided by 2. 4 can be rewritten as 2 times 2 divided by 2. So one of the 2's cancel out, right? Because you can think about this bottom 2 as 2 times 1, right? So one of the 2's cancel out, you just get left with 2.